For the next countermeasures, we call it the countermeasures. It is to avoid the attack. Okay. We can use the statistical attack detection methods. Statistical attack means we can detect group of users who collaborate to push or nuke items. As you know that if you want to attack, it is effective if you can have maybe around 30,000 users. Then, yeah, we need to detect the group of users who collaborate. So it means you need to detect among those 30,000 attackers, we need to check the similarity, or we need to do something. For example, monitor development of ratings for an item. Let's say I want to see the changes in the average rating, or I want to see the changes in the rating entropy, or I want to check the time dependent metrics or bug ratings. Time dependent metrics means maybe weekly. After this week, I want to know the rating on the next week. Is there any big changes or not? And then I will check another week. And yeah, every week we will check if there is no such changes on the metrics. We can say that, okay, that's fine. Or we can use some machine learning methods to discriminate real from fake profiles. So there's also a way to distinguish real or fake. So we can make the binary classification. It is real or fake. So usually we can use like normal and outlier. So in the attack problems, we also need to consider privacy. Privacy means the something about the user information as or customer information. So the problem is to store and manage sensitive customer information. The detailed customer profiles are the basis for market intelligence. So if you know, yeah, I think in Korea last time also happened, the user clicked, okay, so the user profiles has been publicly available. So that kind of things is very dangerous. If we can see the detailed customer profiles, then you can do the segmentation of customers. If you can easily do the segmentation of customers, then you can make easily the attack. So the customer privacy ensurement is important for the success of recommender system. And users refrain from using the application if privacy leaks get publicly known. So if your application is not good, usually users do not want to use your application because it will easily get the attack. So the main architectural assumption of the CF recommender system, CF is the collaborative filtering, is one central server holding the database. Okay. So if you know the very easy understanding about the information system, one server in a company, and then everyone will connect to the server. And if you use this kind of mechanism, so the plain or non-encrypted ratings are stored in the database. So when you have the user one and item one, the rating is 5. You save that information in the database as it is. As it is means it is not non-encrypted, and this is dangerous. So once an attacker achieves access to that system, all information can be directly used. So to prevent such privacy breaches by distributing the information, so yeah, some company they try to do the distributed server. The distributed server means one server is located in maybe Seoul, one server is located maybe in Busan, one server is located in maybe Gwangju. And then the server located in Seoul is only for some users and some items. The server located in Busan is for some users only. So when it is in the distributed server, the attackers will need to have more efforts to get the data. So it is to avoid the exchange, transfer, or central storage of the raw users rating. The other way to do the we call it the data privacy. So there's a mechanism we call it data perturbation. You know what does it mean by this one? Data perturbation. Usually we call this similar to the data masking. Mask. The main idea is to obfuscate. Obfuscate means to make confusion, or sometimes we can say blur the ratings by applying random data perturbation. The server, although does not know the exact value of the customer ratings. So when you save into the server, the user one and the item one, the actual rating is 5, but you blur. You blur it, maybe the value is not 5, but it becomes like 101. Something that the attackers may not easily understand. What does this value mean? But you know that this value means 5. So the accurate recommendation can still be made because the range of data is known. So if you know the how to encrypt to this number and then how to decrypt back to this number, then it is still has a possibility to make the attack. And the computation based on the aggregation of obfuscated data sets, okay, yeah, it is still also a kind of challenge. Okay? It means if I have a server and if I change the value from 5 to let's say 101, so you need to do some computation. The computation is you need to access this data and then you still need to access how to do the encryption and how to decrypt to this value, and then you need to aggregate all the data into one user, into one item, and then to make a matrix. So this kind of mechanism is still costly, but possible. The trade-off between degree of obfuscation and accuracy of the recommendation. So we can like introduce noise. So the data may contain noise. If the data contain noise, then of course the people cannot get the real value. It means the better user's privacy is preserved and the harder the approximation of real data for the server. So it is difficult to get the real data from the server using the data perturbation. So for example, There are three kinds of data perturbation: heavily perturbed, or moderately perturbed, or minimally perturbed. I think you know, okay, if you order in online shop, when you have your name, most of your name will be minimally perturbed. Minimally perturbed means, let's say the name is Hong Gildong. So one of your name will be star. Or you have the moderately perturbed. The moderately perturbed means you will see only one of the name and the other name will be masked or it will be covered. Or if it is heavily perturbed, means the social ID number, for example, this is very sensitive. If you have this number, then the perturbed result is something you cannot know. Maybe we call this is the hash function. So if you learn the data structure and algorithm, we learn about the hash function. So from these numbers, we have a function to create another value as like this one. So the data perturbation is one of the way to deal with the attack. So we can create a kind of factors. So factors of number A, let's say A1 until AN provided by the client, and then try to disguise. Disguise means change the value from A. Then try to discuss A by adding factor R, which is from R1 until Rn. So it means the R1 until Rn taken from the uniform distribution. So we have the minus alpha until alpha. So alpha can be any value, maybe 0.5, 0.7, 0.05, and etc. Or it can be something a very big number. And then the perturbed factor A or perturbed factor A prime is the addition of A1 plus R1. So A1 plus R1, then it will be a new value. And then we have A2 plus R2. So it will be a new value. And then it will be another value, A3 plus R3, and so on until AN plus Rn. So this value will be sent to the server. So the server does not know the original rating, but if the range of the distribution is known and enough data are available, then we can make some estimation about the sum of the factors. So for example, we can do the summation AI plus RI. It means the simple way is to do the summation of A plus the summation of R. Okay, if we can do this approximation, then we can easily check that it will be equivalent to something the distribution of AI. This one is should be I. I. So if we know the distribution of AI, then it is the original data. Another way to deal with the CF with the distribution, we can measure with the distributed CF. The distributed CF means the distributed collaborative filtering with estimated for concordant measures. So it is a trade-off between privacy and accuracy. For the privacy is high when we can change the value, but the accuracy will be very low because we are not sure about the value. But if we use the real value, the accuracy is high. However, the privacy is less. So it's a trade-off between the privacy and accuracy for the perturbation. So that's why we can use the distributed CF with the concordance measures. The main idea, do not use standard similarity measures. So we can use like the person similarity, like in the nearest neighbor. If it is simple like this one, then we can get easily. So the main idea, do not use this standard similarity measures. And we can use the concordance measure. So the concordance measure, we can use it for the comparable accuracy to the person correlation. For example, we have a set of items rated by user A and B. Let's say we have the user 1, user 2, user 3, user 4. So let's have the user A and B. So let's determine the number of concordant. The number of concordant means the item on which both users have the same opinion. Number of discordant means the item on which they disagree. And the number of items for which their ratings are tied, or it means the same opinion or not rate items. Okay, based on the concordant, discordant, and this rating of type, we can use a measures, we call it Somers measure or Somers distance measure. Distance D. So the DA comma B, it means the distance between user A and B. It is the number of concordant, which is the items which both users have the same opinion, minus by the number of discordant, is the number of items which they are disagree, divided by the number of item rating used. So how many ratings that has been used for this method, minus by number of type. Number of type is the number of item for which their rating are type. So it is the method for association between two users. We can have some kind of condition to make the concordance. So if we define the difference between a user's A rating for an item I and A means rating as like this one, F we define a variable F. The F value is the result of the rating minus by the average. So the rating, let's say, we have 4. And then the average, let's say 3.67. Okay, then the FAI is 4 minus 367. Okay, then the result is 0.33. For this one, it means 3 minus 3.67. Then the result is minus 0.67. So you know already how to calculate the mean adjusted rating, okay, in the chapter 2 or 3, okay. And then given a pair of ratings RAI and RBJ by different user A and B for the same item, so such rating will be like this one. We call it concordant if the FAI, this is the result, FAI is higher than 0. And if FBI is also higher than 0. So it means the user 1 FAI, which is 4 minus 3, 7, and the user 2, which is 2 minus 2, if both of them are higher than 0, then they are concordant. Or if both of them less than 0. After we know this, whether it is concordant or not, then we can calculate how many of the item that is concordant. And then we can also check the discordant. Discordant means when they are disagree. Disagree means when the FAI is higher than 0 and the FBI is less than 0. Okay, so it is high, it is less. Or when the FAI is less than 0 and the FBI is higher than 0. So if it is disagree, yeah, it is discordant. Or if it is tight. If it is tight means when the FAI equals to 0 or the FBI equals to 0. Or we can also check if RAI does not exist. So the item is unrated. Or the RBI does not exist. So if it is also not rated. Then after we have the concordance, how many of them is concordant? How many of them is discordant? How many of them are tight? Then we can calculate the distance. So in this case, the D12, okay. D12 means the distance between user 1 and user 2. So if you look at this one, the number of concordant in this case 2 minus 2 is 0. 2 minus 2, 0. 2 minus 2, 0. Okay. Because everything is 0. Okay. Because everything is 0, then yeah, you can check on the type. If it is tight, it is one of them is 0. Okay. Because it is 0, 0, 0, then everything is tight. Then there is no concordant, there is no discordant. So 0 minus 0 divided by the number of rating used. So we have 3. And among of those 3, the number of tight is 3. So the similarity between user 1 and user 2 is infinite. So we cannot find the similarity between user 1 and user 2. So you can check with the user 1 and user 3. So the same, you can look at the number. Okay. This one means the number of concordant. The number of concordant of user 1 and user 3. 4 minus 3, this is positive. 3 minus 2, it is positive. Okay. Then 4 minus average is positive. 1 minus this negative. And then 3 minus average is negative. And 3 minus this positive. Okay. So by using this methods, we can see plus and plus. So it means when they are both positive, it is concordant. So the number of concordant is 1. And then check this one, plus minus, minus plus. So it is discordant. So they are disagree. 1 minus 2. And then we have 3. All of them, we have 3 items, and none of them are type. So it is 0. Then we have minus 1 divided by 3. Okay, minus 1 divided by 3. And the result is minus 0.33. Okay. And it's also the same for the D1 form. Okay, so you can also measure with the same idea. So this is the distributed collaborative filtering with the estimated concordance measures. So for this kind of things, yeah, there is a community building and aggregates. It means the participants of knowledge communities share the information, whether it is inside the community or with the outsiders. And the active user can derive prediction from the shared information. So the information are aggregated based on the model base, for example, SVD. So individual users rating are not visible to user outside the community. And use the cryptographic scheme for secure communication between participants in the network. Usually, maybe nowadays in the idol in Korea, K-pop, okay, they have the community, fans community. So when you are in the community, then everything will be shared properly and they are trusted result, or they have a trusted information. So within the community, then they can share everything and you can give the recommendation freely. So, yep, we reached the last. Um, there are many research about attack. It means we need to check the vulnerability of some existing method. So the traditional methods, of course, they have some vulnerability or they are reluctant about their attacks. And specially designed attack models may also exist for up to now rather than stable methods. So you need to find out if you have interest on this attack. Okay? So you need to find out a very specific model. And the incorporation of more knowledge sources or hybridization may help. The practical aspect, no public information on large-scale real-world attack available. You know what does it mean? No public information on large-scale real-world attack available. You cannot get the data. There is no data that share about attack. So you cannot do research on that one. What you can do about the attack is to make simulation. So you can provide a fake data by yourself. Generate the fake data by yourself and then try to figure out whether it is attack or not. So that's very complicated things when you do research. Yeah. And usually in the practical aspect, the attack size are relatively high. Okay. When we do in our research, maybe we just make a very small attack, but in the real world, the attack is very high. And of course, this one, we need to do some research collaboration. You cannot do this kind of research by yourself. You need to ask some industries to collaborate with you if you want to do the research on this domain. Okay, so that's the end of this attack-based recommender system. So you learn about the characteristic of the attacks, and then we learn about the models like the push and nuke. Do you remember? Push is to give high ratings. Nuke is to give small rating. Okay. Random means we just make a random numbers based on the distribution. Average. So we just put the average rating of the particular items. Bandwagon. We put the popular items, or we want to focus on the popular item so that the similarity will be very high. Mix. So mix means we can combine those models into mix. And we learn about the AOP. AOV. AOP, what is it? Average over popular. So in the mix method, we can use the AOP method. And we learn also about the effectiveness analysis. We learn about the robustness, the stability, and the rank metrics. And we also learn about the countermeasures and the privacy aspects. Okay. Any questions?